Welcome to the class once again. I hope you're all doing good and you're the best of your health. So after practicing the first 5 questions based upon JEE advanced pattern questions that we have already discussed in this chapter, system of particles and rotational motion. We have discussed questions on center of mass, on momentum, and even on rotational concept. Now we'll proceed from where we left in the last class. We'll proceed ahead. We'll go with the question number 6 and we'll see next 5 questions how better they will entail us to understand the topic. Let's go with question number 6. We have question number 6 to 8. There are more than one choice option correct. In JEE Advanced examination, you can get question which will be having more than one option as the correct answer. Let me tell you the rule of more than one option correct answer. In this, if 4 options are given, let's say A, B, C are correct. If you mark all the 3 correct, you'll get plus 4 marks. If you mark only A and B, you'll get plus 1 for each of the option as the correct answer. If you mark any of the incorrect answer, the entire question will be actually taken to be wrong. So you have to mark as many options you get to be correct, you mark as many those options as the right answer. So without taking more time, let's go ahead with the question. 6th question, a solid sphere is in pure rolling motion. So first of all, we can see a solid sphere is in pure rolling motion on an inclined surface having inclination theta. So we have an inclined surface, an inclined plane, we have a solid sphere. I believe that you can understand from solid sphere, its moment of inertia will be 2 by 5 mr square. Let's go ahead. It's rolling, it's in pure rolling motion. That means it is not slipping. That means you can relate linear velocity with angular velocity as v equals to r into omega. Let's go with the option. Option number A says that frictional force acting on the sphere is F equal to mu mg cos theta. This is the first option. Second, F is dissipative force. This is the second option. C, friction will increase its angular velocity and decrease its linear velocity. That is option number C. And D, if theta decreases, friction will decrease. You know, if you have not studied this concept of rolling on an inclined plane, you would be thinking that frictional force acting on the sphere is F equal to mu mg cos theta. I have discussed with you all the case in our regular class. When a body rolls, it performs pure rolling motion and comes down. Let's go ahead, let's try to frame the equation. Already we have framed the equation in the class. What will be the value of friction based upon its mass, moment of inertia? Let's go ahead and try to reformulate once again the equation, because you may forget the equation on the day of your examination. So how you are going to actually frame it? Let us go ahead. In this case, we have an inclined plane as shown here. It has an angle of inclination that is given as theta. Now it has been given that there's a complete sphere. There's a solid sphere. Let me make it clearly. We have a solid sphere. It performs pure rolling. Let's say omega is the angular velocity. Very conveniently we can now see omega I have made that can be taken to be as 0 and then it starts rolling motion. The forces acting on it will be C. In what direction they will be acting? First of all, as it rolls, try to understand the friction force acting on the body. This part tries to rub it, and frictional force acting on it will be along this direction. This will be the direction of frictional force. Next thing, let us write down the weight mg that will be acting along this direction. Next, mg is its mg component, mg sine theta. Now I have marked mg from here. It will be acting from the center. From that you can make out. So I have marked here so that the point of contact I am changing just to understand how you are going to actually equate the forces. So you don't have to worry about this point of contact. It will be acting at the center, but don't worry about it. Next thing, I need to actually resolve mg into 2 components. If this is theta, we all know that this will be theta. This will be mg cos theta, and we will be having the other component that will be acting on it. Let me show the other component as mg sine theta. The body will be coming with an acceleration. Let's mark this acceleration as a. We all have done this in the regular class, but once again let's do. For the equating the forces parallel to incline, equating forces parallel to incline. See what we will be obtaining equating forces parallel to incline. We will be having mg sine theta minus f will give us m into a. So first equation will come out to be mg sine theta minus friction force will be equal to m into a. This will be equation number 1. Quite simple. Now you see, second equation, n will be equal to mg cos theta. That's not required. N equals to mg cos theta, clearly we can see. Now for rotational motion, first of all, now see mg sin theta, although I've shown it here, it will be acting at the center of mass. Mg sin theta will not provide any torque. For clarity, if you are confused here, for clarity reason, I will just mark this mg sin theta to be acting at the center of mass. Need not to worry about it. Now you see, F will create a torque. Then we have torque due to frictional force. Let us write that torque due to frictional force formulating the torque equation. We can write the torque due to frictional force, that will be equal to I into alpha. That is what we can write, I into alpha, where alpha is the angular acceleration. So instead of omega for angular velocity, it will be better to mark this as angular acceleration, that is alpha. Now you will see torque is equal to I into alpha. Torque will be equal to, this will be radius, R into F. That will be written as R into F. So we can write R into F will be equal to I into alpha. First of all, this thing we have clearly taken down. Now using these two equations, we have to actually frame an equation for the frictional force. Next thing you see, alpha can be written as, and if we eliminate, first of all, if we eliminate frictional force using both the equation, we'll be having F is equal to I alpha by R. We can write in this way, F is equal to I alpha by R. Adding both the equation number 1 and 2, we will be having mg sin theta minus f and plus f will be cancelled out. Mg sin theta is equal to ma plus I alpha by R. Mg sin theta will come out to be ma plus I alpha by R. From here, can you frame an equation for linear acceleration, or can you frame an equation for alpha, because that will help us to know the value of frictional force. We can write A equals to R into alpha, that's quite clear. A can be written as R into alpha. So m R alpha plus I alpha by R will give us, this will be equal to mg sin theta. Let me rub this line. This line is not required. Let me rub this line. Otherwise you will get confused. Let me rub this line. Now you see here, easily we can frame an equation for the value of alpha. We will be obtaining the value of alpha as mg sin theta. Take alpha as common. You will be getting mr plus I by R. This is the term you will be getting. Alpha will turn out to be, this will be equal to mr square plus I. R will be in the denominator. Alpha will turn out to be mg r sin theta divided by mr square plus I. This you will be obtaining mr square plus I. This is the value of alpha. Can you substitute here? We are going to obtain the value of frictional force, and let us see how it is actually dependent on all the given variables. So let me use this part. Finally, friction is equal to I into alpha by R. From here, this will obtain us, this will give us alpha mgr sin theta, mgr sin theta divided by mr square plus I. Clearly you can see mr square plus I. So let us put this as mr square plus I. We have provided I into alpha divided by R. So let me mark here divide by R. Clearly the final equation will turn out to be F is equal to mg img sin theta img, or instead can we just use this term and we can keep it in the denominator. Then we'll be getting this as F is equal to mg sin theta. What I'm doing, I'm bringing this I here in the denominator of this fraction. So we'll be having this as 1 plus I by and mr square by m. Sorry, this will be mr square by I. We have done I by I will give you 1 and mr square by I. This will be the value of frictional force. Clearly, frictional force is not equal to mu mg cos theta. That happens when a block comes down. When a block actually slides over an inclined plane, then we see that the case of limiting friction force acts. Then friction force equal to mu mg cos theta. But here this is not a block. This is actually a rotational. It's performing, a body is performing rotational motion. That means you have a sphere, a circular body which can actually perform rotational motion on an inclined plane. It's a case of rolling motion. So frictional force is not mu mg cos theta. Frictional force is mg sin theta divided by 1 plus mr square by I. This is the value of frictional force. Now let's go ahead. Let's see here. First option of frictional force acting on the sphere is F equal to mu mg cos theta. No, this is incorrect. B, F is a dissipative force. First of all, in this case, once again, try to understand. Frictional force is acting at the bottommost point. Try to understand. At every point of contact, first of all, there is no displacement due to frictional force. Regularly, I have told you this point in our regular classes. Friction force is not going to do any work on this body. This is not a case of a block which is sliding on the inclined plane. It's a case of a sphere which actually performs pure rolling motion on the inclined plane. So friction force, it will not do any work. It's not going to decrease. It's not going to play any role on the kinetic energy of the body. So frictional force, dissipative force, incorrect. C, friction will increase its angular velocity and decrease its linear velocity. Now try to understand, friction force is going to increase its angular velocity. Frictional force, torque of the friction force equal to I into alpha. We have written this, friction force equal to I into alpha. That means, try to understand from this equation, I into alpha by r. Due to frictional force, angular acceleration is there. I and r will be constant. Due to frictional force, angular acceleration will be there. When there will be angular acceleration, quite obvious, that means angular velocity is going to increase. That is what is the role of friction. It's going to increase the angular velocity. So friction force will increase its angular velocity. Yes, this is correct. And decrease its linear velocity. Decrease its linear velocity, you see here, mg sin theta minus f is equal to ma. Here it is in negative. That means as more the friction force, less will be the value of linear acceleration. That is, it is going to decrease the linear velocity. Frictional force is acting along this direction. Try to understand. It's acting opposite to the direction of motion of the body. It's going to decrease its linear velocity. That is the beauty of JEE advanced question. They are asking such questions which are so much conceptually deep they are. This is also correct. So option number C will be correct. D, if theta decreases, that means if theta decreases, friction force will decrease. Check the equation of friction force once again. F is equal to mg sin theta. Can we write this as F is proportional to sin theta? Rest of the terms can be treated as constant. So decrease the theta, decrease the friction force. That is what we can obtain from this equation. So option number D is also the right option. If theta decreases, friction will decrease. Yes, it is going to decrease. So D is also one of the right answer. So if you mark C and D both as the correct answer, you are going to get full marks plus 4 marks. But if you answer only C, you are going to get only 1 mark. If any one of the options you touch as the right answer, A or B, your entire question will be taken to be wrong and you will not be marked for this question. So that is what you have to take care, you have to take caution while answering multiple choice question. It's a very good question as in JEE advanced examination, so more than one option correct. After analyzing the entire situation, we have reached on to the result C and D are correct. Although I have elaborated each step, if you remember, if you regularly solve questions for a body falling on an inclined plane, rolling on an inclined plane, you know the equation F is equal to mg sin theta divided by 1 plus mr square by I. You can go ahead and you can actually do in one go. Need not to go for the enough elaboration as I have did here. I have explained each of the steps so that you can understand the solution quite easily. It's a very good question. I hope you have understood how to solve such kind of question. Let me just clear the board for you all, and we will start with the next one. Hope that you are liking this session and you are finding it helpful for you all in your preparation. Let's go ahead with the next question of the class. Question number 7. A point mass of 1 kg collides elastically with a stationary point mass of 5 kg. So we have 2 point masses are going to collide with each of them. After their collision, the 1 kg mass reverses its direction and moves with a speed of 2 meters per second. Which of the following statements are correct for the system of these 2 masses? A, total momentum of the system is 3 kg meter per second. B, momentum of 5 kg mass after collision is 4 kg meter per second. C, kinetic energy of center of mass is 0.75 joule. D, total kinetic energy of the system is 4 joule. First of all, try to understand how to do here. It says that point mass of 1 kg collides elastically with a stationary point mass of 5 kg. See here how we are going to do. Point mass, we are going to have two point masses which are going to collide with each of them elastically. Let's say I have taken this as 1 point mass. Its mass is, let's say, m1, that is given as 1 kg. Let's say it is moving with an initial velocity u1. We don't know, its value has not been given to us. A point mass of mass 1 kg collides elastically with a stationary point mass of 5 kg. So we have the second point mass whose mass is m2, and let's say m2 is 5 kg, that has been given. Its velocity is given as u2, that is 0. Second thing given that after collision, the 1 kg mass reverses its direction and moves with a speed of 2 meter per second. These are the second important point. So after collision, if I draw the situation, what's happening? See here, this body, the first body, that of mass 1 kg, it moves in opposite direction with a velocity v1, that is given as 2 meter per second, as you can see in this statement. Let's see the effect on the second body. This is 5 kg body, m2. Let's say it moves with a velocity v2 along this direction. So we are unaware about v2, we are unaware about u1. We are aware about the final velocity of m1. Now in our collision case, I have taught you about what is the final velocity attained by an object after collision. So can we write v1, which is the final velocity? This can be given as in terms of initial velocity of both the bodies, m1 minus m2 upon m1 plus m2 multiplied with, this will be multiplied with u1 plus twice of m2 upon m1 plus m2 divided by, multiplied with u2. This is what formula I have taught you in the regular class. m1 minus m2. So we will be having 1 minus 5 minus 4 divided by m1 plus m2, that will be 5 plus 1, 6 kg. So let me write this as 6, and u1 we don't know, let's keep it as u1, and v1 comes out to be, v1 is given as 2 meter per second towards left. I believe that's okay with you all, minus 2, because velocity is towards left. u2 is 0, so need not to worry about it. From here you can get the information for the velocity u1. This will come out to be, u1 will come out to be 3 meter per second. First thing, u1 will be 3 meter per second. We got the first information. Now let's see the first option. Total momentum of the system is 3 kg meter per second. After finding the initial velocity of the first object, can we comment on the total momentum? Because the collision is elastic. See here, it says that collides elastically. The collision is elastic, that means there will be no loss of, there will be no change in momentum, or clearly you can say that mass into velocity, that will remain constant, and initially only one object is moving. That is, you can just multiply mass of the body with the initial velocity of the object. So initial momentum, mass 1 kg, mass into m1 into u1, m1 is 1, u1 is 3 kg meter per second, and every time this momentum will be conserved. Whether the collision is elastic or inelastic, the momentum will be conserved. So mark the initial momentum as 3 kg meter per second, that is going to remain constant entirely. Total momentum of the system is 3 kg meter per second. Yes, that's the right statement. Let's check the second option. Momentum of 5 kg mass after collision is 4 kg meter per second. For this, we need to know the final velocity of the 5 kg, because we are unaware about the 5 kg mass final velocity. We have known the initial momentum. How to find out the final velocity of the second body? Clearly you can see here, is 3 kg meter per second. Remember this momentum? So I am going to use the concept of momentum to find out the final velocity of second object, that is this object. This was moving towards left with a velocity of 2 meter per second. So we can write initial momentum is equal to final momentum. We have 3 kg meter per second. Let's keep it as only magnitude 3. Final momentum you see here, 1 kg mass moving towards left with 2 meter per second. So minus, we can write this as 1 kg mass minus 2 plus 5 kg mass into its velocity, that is, let's say we have taken this as V2. This will come out to be 3 plus 2, 5, 5 by 5, V2 will come out to be 5 to 5, 1 meter per second. I believe that this is clear to you on how V2 is 1 meter per second. B option says that momentum of 5 kg mass after collision is 4 kg meter per second. Let's check. No, it's not 4 kg meter per second. So momentum of 5 kg body will be equal to its mass into its velocity, that is 5 kg into 1. This will come out to be 5 kg meter per second. From this, what do we get? We get that this option is incorrect, so don't mark option number B. C, kinetic energy of the center of mass is 0.75 joule. Let's check the kinetic energy of the center of mass. Now see here, the collision is elastic. I have explained to you all in the regular class, if the collision is elastic, then the kinetic energy will remain conserved. For the kinetic energy to remain conserved, that means whatever the kinetic energy possessed by this body before the collision, that will remain conserved. That will not change. Its momentum we know that is 3 and its mass given as 1. So can we write this as kinetic energy, we can write it as P initial whole square by twice of mass m1, because initial momentum is only due to this body m1. Now initial momentum we have evaluated that as 3, so we can write this as 3 whole square by 2 m1, that is 1. This comes out to be 4.5 joules. P square by 2m, that comes out to be 4.5 joules. So that is not 0.75 joule. We can clearly see that is not 0.75 joule. Total kinetic energy of the system is 4 joule. Let's see the total kinetic energy of the system. That will be actually 4. You can clearly check that even that is 4.5 joule that we have obtained. And if we evaluate here the total kinetic energy, that will turn out to be just kinetic energy of one body plus kinetic energy of the second body is what we have to do. So what we do, take note till here. I'll start from the other end. Take note till here. So I believe that you have noted down, and you have noted down that what direction we are proceeding. You see here this kinetic energy, this is the initial total kinetic energy of the body, 4.5 joule. So if we evaluate this, we are going to get total kinetic energy. This will be the initial kinetic energy. This is the total kinetic energy which will remain conserved. But here comes what the examiner is seeking from you, the concept. It has said that the kinetic energy of the center of mass is 0.75 joule. For it, how you have to proceed. Since we got total kinetic energy, that is 4.5 joule, for center of mass kinetic energy, you will be using the momentum of the system divided by twice of mass of center of mass. Now center of mass will be having the initial momentum of the first body which was moving, but its mass will be also due to this object also. So total mass will be 1 plus 5, that will be 6 kg. So if we write here, this will be 3 whole square divided by twice of mass of center of mass will be 6 kg. So 9 by 12, this will be the answer. So 3 by 4, it will come out to be 0.75 joules. So option number C, that is kinetic energy of center of mass, that is 0.75 joule. Let's go with option number C. This is correct, and total kinetic energy is 4.5 joule, not 4 joule. So this is incorrect. So option number C is correct, option number A is correct, B and D are incorrect for this question. I hope that you have obtained how to solve such question. Let's go ahead with the next one. So you would have understood that JEE Advanced examination, they are seeking deep understanding, in-depth understanding from you all. If you are trying to by heart things, it will be of no use, but you have to understand the application of the concepts. Let's go to the next question. 8th, a uniform bar of length 6a, uniform bar of length 6a and mass 8m. See that its mass is 8m, lies on a smooth horizontal table. Light is lying down. 2 point masses m and 2m moving in the same horizontal plane. M and 2m in the same horizontal plane with a speed 2v and v. Its speed is v, its speed is 2v. Respectively, strike the bar as shown in the figure and stick to the bar after collision. That means the case of inelastic collision, denoting angular velocity about the center of mass, total energy and center of mass velocity by omega, E and Vc respectively. We have after collision, velocity of center of mass equal to 0, omega equal to 3v by 5a, omega equals to v by 5a and E equals to 3 by 5 mv square. So you have to check what is the angular velocity, what is the energy, what is the velocity of center of mass. Now see here, since it's lying on a smooth horizontal table, this point is important. Seems simple, but smooth horizontal force table, that means no external force will be acting on the system of 2m and m on this plank. Next thing you see, if we talk about the momentum, you see linear momentum I'm talking about, 2mv is here, 2m into 2v, so 2mv will be here. So net initial momentum will be 0. So if we write net initial momentum is equal to 0, so net final momentum has to be 0. So net final momentum is to be 0, so velocity of center of mass will come out to be 0. So linear velocity of center of mass will come out to be 0, so option number A is correct. Now for omega, you see how we are going to find the omega. So what will happen, this body, this plank is going to rotate. Try to understand. We know that net initial angular momentum will be equal to final angular momentum. Final angular momentum will be I into omega. That is what we can make out. It will be rotating about this axis. Try to understand with this figure. I am not going to draw another figure. Try to understand. So angular momentum due to this body, this distance is given as A, you can see, and this distance given as 2a. So we can write, since no external torque, so we can write angular momentum will remain conserved. So we can write angular momentum due to this body, its velocity is here. We have to do r cross p. If we do r cross p, we will be getting, thumb is pointing outwards. Angular momentum direction is out of the plane of the board. In this case, my right hand this, m into 2v, the linear momentum is here, r is here, r cross p, again the angular momentum direction is outside. So we will be getting, both direction is pointing outside, we can easily just add them, 2m into v multiplied with distance a, so we can write 2m into v multiplied by distance a plus, this is also 2m into v multiplied by distance 2a. 2m into v multiplied with distance 2a is equal to, we know that moment of inertia I into omega. This is what we can write. 2 MVA plus 4 MVA will give you 6 MVA is equal to I into omega. Now what about moment of inertia I? This is the plank, it's rotating. If I talk about the moment of inertia of the entire system, we will be having I of entire system will be I due to plank, that's given as uniform bar, or I will write I bar plus I due to mass m plus I due to mass 2m. I of bar, that will be equal to 1 by 12. Its mass is given as 8m, 1 by 12, 8m into length 6a whole square. That is what we can do. 1 by 12, its mass is given as 8m, its length is given as 6a whole square. This is what we can do. Next, I due to m. You see here this mass m, its distance is 2a, mr square we have to use, so m into 2a whole square, m into 2a whole square plus due to 2m, we will be having 2m into its distance a whole square. This is what we have to do as we have learned. 1 by 12 ml square we have used here, then mr square we have used here. So this will come out to, you see, a 6 square 36 you will be getting, and here you will be having, so I am going to simplify this, we will be having 8m multiplied with 6a whole square and divided by 2, this is what we will be getting. So again this will go 4 times 4 is 24, 24 ma square plus 2 ma whole square plus 2 ma whole square will give you 8 ma whole square, 4 plus 2 6, sorry, 6 ma whole square. So you are going to obtain 30 ma whole square as the moment of inertia. 30 ma whole square, you have to just substitute 30 ma whole square here, you will get the value of, don't get confused, moment of inertia is 30 ma whole square. Substitute here in this equation. So if I mark this equation number 1 and I net as equation number 2, so substituting the value of I net in equation number 1, 6 MVA is equal to I net 30 ma whole square multiplied with omega. Clearly you can see m cancelled out, 1a cancelled out, omega will come out to be, this will go 5 times, omega will come out to be v by 5a. V by 5a is the value of omega that you can clearly see here, v by 5a will be the value of omega. Let's check, we are having option number C, omega is v by 5a, that is the right answer. Omega is 3 by 5a, that is the incorrect. Now we have to check about the energy, the kinetic energy we need to check about. This is the case of, and it says that they stick to the bar after collision, denoting angular velocity about the center of mass, total energy and center of mass velocity by omega, omega E and Vc respectively, we have after collision. After collision we need to talk about the value of total energy. Now easily you can evaluate, you know the value of I, you know the value of omega, so half I omega square you can do, and you can find out the value of total energy. So if we go ahead, if you write down total energy is equal to half I omega square. So half I value have evaluated as 30 ma whole square multiplied with omega whole square, that is v square by 25 a square. This is what we can actually write. A square will get cancelled out. We will be having, this will go 5 times, this will go 6 times, this will go 3 times. So we will be having 3m 3 by 5 mv square. This is the term we will be having, 3 by 5 mv square. Let's check, yes, energy is 3 by 5 mv square. Option number D is also correct. Very good question, has been asked in the previous JEE examination, and this is how you have to proceed stepwise. Easy question, but if only you are knowing about each of the concept of momentum conservation, angular momentum conservation, you can clearly mark the option A, C, D as the right and option B as the incorrect answer. So now you will be having the idea what kind of questions will be asked in your examination. Let's go ahead with the next question of the day without taking more time. Assertion and reason. Let's go ahead. Statement 1, 2 cylinders, one hollow, that's metallic, and the other solid, that is made of wood, with the same mass and identical dimension are simultaneously allowed to roll without slipping down an inclined plane from the same height. The hollow cylinder will reach the bottom of this inclined plane first. Statement 2, by the principle of conservation of energy, the total kinetic energies of both the cylinders are identical when they reach the bottom of the incline. Let us talk about first, the hollow cylinder will reach the bottom of the inclined plane first. Now, if we talk about blocks coming down through an inclined plane, then they reach the bottom of the inclined plane, and that is not dependent on their mass, they will reach together. But here the case is different. Let's see here. It says that, now I am not going to do elaborate equations because already I have done in the question number 6 and already have done in the regular class also. In the case of rolling motion, let me recall you, acceleration is not directly dependent upon the kind of acceleration is not actually constant. That is dependent upon the kind of object. As much less is the moment of inertia, the more will be the acceleration. The less the moment of inertia, more will be the acceleration. Now see, for solid it's a case of we have its cylinders. For solid cylinder we have moment of inertia is 1 by 2 mr square, and for hollow we have moment of inertia as mr square. This is lesser. You frame equations as I did question number 6 and try to find linear acceleration that will be dependent on moment of inertia. So lesser the value of moment of inertia, more will be the acceleration. With more velocity, it's going to reach at the bottom. So solid cylinder will reach first. Solid cylinder will reach with more velocity, and it will reach first. So it says that hollow cylinder will reach the bottom of the incline. No, this is incorrect. Solid cylinder will reach first. Solid cylinder reaches first as it has more acceleration, more value of linear acceleration. Let's go ahead. Statement number 2, by the principle of conservation of energy, the total kinetic energies of both the cylinders are identical when they reach the bottom of the incline. Now understand, there is no dissipative force acting on the body. Total kinetic energy will be conserved. Both are they are falling through same height. So initial potential energy will be the same. So final kinetic energy has to be the same. Combined rotational and linear kinetic energy, their kinetic energy will be same. So this statement is true. Now in the case of exertion and reason, you have to choose the option based upon which statement is correct. So option number A, when both are correct and statement 2 is the correct explanation of first. Option number B, when both are correct but this is not the correct explanation. Option number C, if this is correct, this is incorrect. Option number D, when statement 2 is correct and 1 is incorrect. So D matches, so you have to answer D as the right answer for this question. So there was lack of space, so we have not given all the 4 statements, but I have actually read out this statement, what statements you have to follow. D, 2 is correct, 1 is incorrect. This is the answer of this question. Let's go ahead. This was a very good question. Question number 10. 3 objects A, B, C are kept in a straight line of a frictionless horizontal surface. This is not off, this is actually on. Let me just make a small correction. On a frictionless horizontal surface, these have masses m, 2m and m, 2m and m respectively. The object A moves towards B with a speed of 9 meters per second. So let me mark here, object A move towards B with a speed of 9 meters per second. This is the first information given, and makes an elastic collision with it, elastic collision with A and B. Thereafter B makes completely inelastic collision with C. B makes an inelastic collision with C. All motions occur in the same straight line. Find the final speed of the object C. A is colliding with B. Can we find out the velocity of B after collision when A collides with B? See here, let's say velocity of B initially is given as 0, no doubt on that. The final velocity of B becomes, let's say after collision, using this same figure, we can say that its final velocity is given as Vb. And for here its initial velocity is given, so I will take this as UA. That will be better notations for having no confusion. I have given you this. So final velocity of B will be given as mass of B minus mass of A upon MB plus MA. This is how we do, multiplied with the velocity of, you must be remembering I have discussed this formula with you all. This will come out to be velocity of B plus twice of mass of A divided by mass of A plus mass of B multiplied with velocity of A. This is how you have to approach. Now you have to only put up the values. Velocity of B, that is 0, need not to worry about it. Twice of mass of A, that is given as M. MB plus MA, that will give you 3M multiplied with velocity of A, that will give you 9. This will come out to be 6 meter per second. Velocity of B comes out to be 6 meter per second. So what do you do? Take note till here. Let me start at the other end. Take note till here. I hope that you have noted down this end, that is velocity of B comes out to be 6 meter per second. Now, although between B and C we are having an inelastic collision, the momentum will remain conserved. So, as B collides with C, as momentum will remain conserved, so momentum before collision, let's take that as initial, and momentum after collision, let's take that as final. For B, so mass of B multiplied with velocity of B is equal to combined mass of B plus mass of C multiplied with velocity, their common velocity, which will be the velocity of C also. So we're taking that as V. So V will come out to be, let's do mass of B into VB multiplied with MB plus MC, that will, its value we will be putting, don't worry. So we'll be getting mass of B as 2m multiplied with 6 divided by 2 plus 1, 3m, that's it. So we'll be having 12 by 3, that is equal to 4 meter per second. That is, this is the common velocity of B and C when they stick together. In inelastic collision, they stick together. This is the common velocity. That is, velocity of C also will be also 4 meter per second. Easy question. So, advanced examination, some questions will be easy, which you can easily solve. So 4 meter per second is the answer for this. So, in your examination, you have to circle the bubble which is having numeral 4. So take the answer as the 4 in your examination. That is what you have to do. So this was all. These were a set of very good questions that we have discussed in our JEE Advanced exercise, and hope this will be helpful for you in understanding what kind of questions come in your examination and how deeply you should have the knowledge of concepts in this chapter. Very important chapter. Practice more questions. That will be certainly of great help to you all. And wishing you all the very best, and thank you for joining me. I'll meet you on the next class. Thank you, everyone.